Hi guys, this is the note video for topic 1.1, counting significant figures. If there's one topic that's going to follow you for the rest of the year and into your upcoming science courses that are going to be available to you, significant figures is something that's not going to go away. The one thing that's key about chemistry is a lot of the concepts that we cover are something that snowballs and they are things that stay with us. So I've broken up significant figures over a series of days. And so the first thing is they're going to seem kind of strange to start out because it's something brand new to everybody. The next thing is, I cannot emphasize this enough, is that if you are not understanding it, you need to reach out to me now. Because when we get to the point of doing actual chemistry calculations, the expectation is that you can count and round to appropriate number of significant figures. So again, as we work through these first couple days, it is super, super important that if you are struggling, that you reach out to me so we can arrange a time to talk over Google Meets so we can get things straightened out. So go ahead and we can start filling in the notes. So essentially, significant figures are important because of devices that we use to measure. So let's say you had this bar that you were measuring and you were provided these three different rulers. You can see right away that there's very different amounts of increments provided by the ruler. And you could safely assume that ruler C would be a much more accurate measuring device compared to instrument A. So significant figures are important because of your measuring device. And so the basic idea is that when you make measurements, they can only be as accurate as the instrument that you used. So if you had ruler A versus ruler C, what you could record as a measurement for that object is going to be significantly different. So the big thing that we really strive for in chemistry is that when we make measurements, that you know to a certain degree the measurement of the object. The last thing that all measurements should include is an estimated digit. And so we will work on how do you estimate a digit and to how many digits should you record an answer. That's not our battle for today. What we're working on today is just, can you count how many significant figures are in a value? So we're going to do a little geography lesson. So in the time that I have been doing chemistry, which has been a while, significant figures were always taught to me using this very, very long list that will talk about zeros and when they're significant and when they're not significant and so on and so forth. And I came across this Atlantic Pacific rule, and it basically takes this long list of obnoxious rules and it boils it down to two. And if there's one thing I like, if there's a simpler way to work through something, we're going to work through that. So the first thing you have to understand is where these two things are, because it's, again, providing you a resource to work through these. So the Pacific Ocean is on the western coast. So we're going to label this as Pacific. And on the east coast, we have the Atlantic Ocean. Okay. So what that actually stands for is if a number has a decimal present or not. So we use the Pacific rule when the number has a decimal present. So P for present, it goes with P with Pacific. So Atlantic means that the decimal is absent. Absent goes with Atlantic. Okay? So when we work through this, we're going to start with the Pacific rule. So the first thing that you do is if you see that the number has a decimal in the number, you start at the left. You find your first non-zero and count to the right. So I have an example. So we have 0.08214. Okay. So let's say I want to know how many significant figures are in this value. So what we need to do is you first see that it has a decimal present in the number. And so what you do is you start at the left. So I'm going to start over here. Okay. As you make your way from left to right, we're going to start counting at our first non-zero. So as I make my way over, well, 0 is obviously a 0, and so is this. So my first non-zero in the digit is this 8. So what I like to do is as I start counting is I underline, or you could use a highlighter, at your first non-zero being the 8, and you draw an arrow all the way to the right. So now we're going to count how many values we underlined. So there's 8, 2, 1, 4, 0. This number has 5 significant figures. Okay. With the Atlantic rule, this is when we don't have a decimal in the number. So you start on the right-hand side. And then you start at your first non-zero. And you're going to count to the left. Okay. So another example is we have 108, 311, 00. So in this particular example, we can see that there is no decimal in the value like we saw in the Pacific side. So this side, again, you find your first non-zero and you count to the left. So we're going to go right to left. So 0 and 0, so those are obviously zeros. So the first non-zero that I see is this 1. I'm going to draw an arrow and I'm going to draw it all the way to the left-hand side. And so we underline the 1, 1, 3, 8, 0, and 1. So this value has 6 significant figures, or sig figs. Okay? So this is the 2 rules. So you have to determine, is there a decimal or no decimal? If you remember, the Pacific Ocean is on the left-hand side. That means you start at your left and you go to the right. The Atlantic Ocean is on the right-hand side, so you start on your right and you go from right to left. So I have a table that we're going to work through to practice. Again, right now, I know this is probably seeming a little bit strange. The first thing I just need you guys to get through is this rule on how to count them. We'll start looking at application more down the road. So you have to determine in this table, is it Atlantic or Pacific? So this one is Pacific because there's a decimal present. So you start from the left and make your way to the right, starting with your first non-zero. Well, right off the bat, my first digit is a non-zero. So I'm starting here, underlining everything to the right. So in this particular answer, there's 3 sig figs. In example B, there's no decimal, so that means Atlantic. You start from the right, you make your way to the left. You start at your first non-zero, which is the 6. Underline everything going this way. This has 3 sig figs. In example C, we have 30.40. There is a decimal present. Decimal means Pacific, which means you start from the left at your first non-zero. Looking at the value as I go from left to right off the bat, 3 is a non-zero. So you go all the way to the right. That means we underlined everything. This value has 4 sig figs. In example D, we have 104. Decimal is absent, so this is the Atlantic rule. Atlantic rule means you start at the right and make your way left. We start at our first non-zero, which is the 4. Count all the way over. This has 3 sig figs. In example E, we have 300. Decimal is absent, so we use the Atlantic rule. Go from the right, go to the left. You start at your first non-zero. So my very first non-zero is this 3, and that's all I have. So this is 1 sig fig. If we take a look at example F, Notice that I tacked on a decimal to that. So there is a difference between E and F, and we'll talk about that here in a second. So the decimal is present, so we're going to use Pacific rule. That means we will go left to right. So if you find your first non-zero, it's 300, we go to the right. This is 3 significant figures. This means letter F is a much more accurate measurement than letter E. This means there's less uncertainty in that we're saying that this is spot on at being 300, as where without a decimal, there's some room for interpretation with that estimation. We'll talk about that more as we start looking at devices, how to measure them to the correct accuracy. In example G, we have decimal present. That means that's going to be the Pacific rule. So that means going left to right at your first non-zero. As I make my way over, the first non-zero is this 3. Go all the way to the right, and this is going to have 3 significant figures. Now, if you want to count significant figures in something that's in scientific notation, you ignore this times 10 to the negative third. You look only at the base number. So we only look at that 3.02, which decimal is present, so means Pacific. We will go left to right from our first non-zero, 3 to 2. So this has 3 significant figures. Again, that times 10 to the negative third will not impact how to count. What I would like you guys to do now is please pause this video. Please see if you can solve these. And once you've solved them, go ahead and play this video and check and see how your answers turned out. This will give you a good insight if you're ready for the homework or if you still have questions, and that way you can get a hold of me and we can talk about where are some points that you're struggling. So like I said, go ahead and take a moment to pause and work these problems out. Okay, so I did my underlining rule to show if I used Atlantic or Pacific, and I have my answers recorded in terms of how many significant figures these following values have. If you had some hiccups and you need some help, please feel free to reach out to me. Otherwise, your homework for today is just going to be practicing how to count significant figures.